So, hello everyone. Welcome to this webinar on Spectral Unmixing in FCS Express 7. Hi, Andrea Valle. I'm here today with Kea Ghosh. Kea will take care of the question section. So again, feel free to type in any question you want during the webinar, and we will try to answer in real time. Otherwise, we'll keep the questions for the end. Now, the agenda for today. What I want to do is to give you a very basic overview of the spectral unmixing, so why we are here today, in terms of a little bit of theory, let's say. And then we will see how to do that in FCS Express. So we will have a look at the spectral unmixing user interface. You might be already familiar with FCS Express if you are here today. So I will not go through the basic of FCS Express, like opening plots and gates. Let's give that for granted. Then we will do some practice. And I actually put together 3 examples. The first one, as you will see, it's a very basic example in which I have single stain control made with the same type of media, actually like lymphocyte, and that's it. Then in the second one, I will use mixed media. So I will have different type of cells and also beads. And in the third example, we will also extract autofluorescence. So we will do step by step, and we will go from the basic one to the most complex one. Now, I see a question about the phone. Is it better now? Okay. Okay. So first of all, what's spectral unmixing, right? So when you deal with spectral cytometers, okay, instead of acquiring, let's say, a small number of region of the spectral, okay, that can also be like quite a lot, like 20, let's say. But usually with standard cytometers, they do not cover the entire spectrum. While with spectral cytometers, they do cover the full spectrum. So you have a high resolution, and usually the detectors are much more. So, for example, you might have, let me see if I can, I apologize if you heard any bad echo. Let's see.
Is it better now? I apologize. I have 2 microphones and one might be better than the other one. Oh, okay, awesome. So again, I will not repeat everything. So, but anyway, I want to go through the basics of the spectral unmixing. And the idea is that with spectral instrument, you can really acquire the full spectrum. Okay, so you have so many detectors and they cover a small fraction each of the spectrum, and they are really close together that you can really say I'm acquiring the full spectrum. So you have a high resolution on the spectrum. And the other thing to keep in mind is that let's say that a cell it's acquired and you have one spectrum, so one line. Okay, that spectrum for that cell, it's the sum of all the spectra of all the dyes that are on the cells. So in this case, let me zoom in a little bit. I like drawing, so let's do this. So this is like a 10, it's a virtual 10 detector, usually have much more, 10 detector instrument, and you see you have a spectrum. So you have, this is the, on the Y, you have the intensity, okay, of the measurement. And the spectrum, it's like this, then it goes up, and then it goes up. Now, this is the observed spectrum, and this is actually the results of the sum of a lot of different spectra. Okay, one spectra, it comes from one dye, another spectra comes from another dye, and so on. So you see these, okay, in gray, but actually what you have, it's this one. So the issue now is how can we measure the amount of, let's say, signal that comes from dye number 1, dye number 2, dye number 3, dye number 4. Okay, all mixed together, they gives this one. But this is exactly what unmixing is doing. So unmixing is basically trying to measure, to quantify the abundance of each dye, of each fluorochrome, okay, in your single cell sample. Now, a little bit, but just really a little bit of math so that you know what's going on. There are several ways in which you can perform the unmixing. Several, let's say, algorithm can be used. The most widely used is called ordinary least squares. And these basically assume that all the dye contribute in a linear way to the observed spectrum. Now, the formula, it's really easy, and it's this one. Now, I might call this Y, you might call this A, C, and E. I mean, just take home the message, okay? We have an observed spectrum, okay, the measurement, which is the gray one, this one, okay? This is what you observe, and you observe this for you measure this for every single cell in your sample. Let's call this Y. Then we have a library. This is formally called mixing matrix or unmixing matrix, okay? This is a library of reference spectra, okay? Every spectra saved in your library, it's like the signature for that dye. You have a spectra, a reference spectra in the library for FITC, another one for APC, another one for P7, and so on, and so on, and so on. And then you have what you want to quantify, it's C, okay? It's the unknown abundancy, okay, for this dye, for this dye, and for this dye. And then at the end, you have a little bit of error. You cannot remove that, you have some error. But anyway, even if you forget about the error for a while, this formula, it's really simple. It really makes sense. So this one, it's basically these times and a given abundance, and these times and a given abundance, and so on. So what we want to find, it's this one. So unmixing, it's actually doing this. So it's using a library and find out the abundance of each, they're called n member of each dye into that library, okay? The contribution of each dye to the actual observed spectrum. Okay, now this is what's going on. So what we want to do before unmixing, okay, before looking for those unknown terms, it's to create our library. And it's important to keep in mind the following. And this is now allows me to introduce the example one. Remember, when you acquire a spectrum of a given cell, that spectrum is the sum of all the dye, and it's also the sum of the autofluorescence, of the intrinsic autofluorescence background. You can call it as you want. So even when you stain your cells or when you stain your beads with a single dye, a single fluorochrome, okay, what you read, it's this one. So the spectrum, it's still, let's say, composed by the autofluorescence. And then on top of the autofluorescence, you have the actual spectrum of the dye, let's say FITC. And then you have another single stain control. And still, if the media is the same, okay, if the cells used to create the control number one are the same used to create the control number two, it means that the background is the same, the autofluorescence, same media, same cell type. But in this case, I'm adding, okay, the spectrum of another dye, okay? This can be FITC, this can be PE, for example. So in the library, in the unmixing matrix, you need the pure spectra, the signature. So you cannot use what you see here on the left. Okay, how to retrieve, how to calculate the pure signature? Well, it's really easy in this case. You simply subtract from the spectrum of your single staining control, the negative. And in this case, you end up with the pure spectrum signature for this dye. And here you have the pure spectrum signature for this dye. Okay, why I'm telling you this? Because exactly as it happened with compensation in unmixing, okay, when you do with spectral unmixing, we are dealing with spectral data, you still need a negative control. Okay, now the first example is actually this one. I have a bunch of single stain control, not just two, I have few more, but not so many. And they are made with exactly the same cell type. In this case, it's lymphocyte. They can also be made of exactly the same bits, okay? But the overall idea is that the negative, it's the same for all of them. So it's a very basic example, but it allows me to show you a little bit about the user interface. So let me go here. We are here. First example. Those are the dye and the antibody that I'm going to use. This is BV711CD3. If it's too small, let me increase a little bit. It has been stained with the CD3. This is BUV737 with CD4 and so on. If you look at these, you see all those antigen can be found on lymphocyte. So basically, okay, when I need to match the positive and the negative control, I can use lymphocyte. Okay, actually, these on the left, the positive control should match the negative control. Remember, because you are subtracting this one from this one, so you want to remove specifically this one. Right, so I want to remove the autofluorescence. We're not extracting autofluorescence from the sample. We are just creating the library with the pure spectrum. So how to do this? Again, example one, tools, compensation and unmixing. And then we can create a new unmixing definition. It's really similar to what you do with compensation. You see, it's the same dialog. The only difference is that instead of clicking on compensation, you click on unmixing. Then you can also change the name here. You see, you can click here and change the name. If you have multiple unmixing definition, we will see later on that you can have multiple unmixing definition. And then you have this wizard. Let's have a look at these different tabs. So the unmixing matrix, this will be the table containing the value of the library. Now it's empty because we didn't even load any data file yet. So here you will see your library, the actual value. In the option, you have a bunch of options that, for example, allows you to change the suffix that is added as a tag to the unmixed parameter. We will see this later on, but it's good to introduce it. And this is also the suffix that it's added to the plot title when you apply the unmixing. We will play with this later on. So far, we should go here. Automatic unmixing setup. It's a step-by-step procedure. You see step 1 to step 6. Again, it's very similar to the compensation. So step 1, load the single staining control. And I want to load those 5. Okay, we are on example 1. I'm going here and I want CD3, CD4, CD8. Let me move it. CD18, 56, and then I need a negative control. Well, let's say if you know that in every single staining control you have a negative peak, so you have both a positive and a negative peak, then you do not really need to select an external negative control. But if you're not sure about that, or if you still want to use a clean negative control, then you can select it this way. Okay, so I will click on open. Files will be loaded into step 1. What you need to do in step 1 is to review what FCS Express did. You have 4 columns. First one is the data file. It's just the file name, nothing else. Then you have the label. So, you know, before unmixing, you have raw data. It means that you do not have at all parameters like CD3 FITC, CD4PE, whatever. You only have raw detector, UV1, UV2, UV3, UV4, and so on. So after unmixing, you will have the unmixed parameter, which are usually the parameter that you want to work with, right? And those are the labels that you want to use to name those parameters. So my BV711 CD3 unmixed will be actually called CD3 space BV711. FCS Express automatically grabbed these from the file name. Now, if for some reason in the file name you do not have any meaningful, let's say, label, FCS Express either will not put anything here or will do something strange, like it will type like, I don't know, FL1, if the file name just report FL1. So no worry, you can just go here and write whatever you want. So like text, you see here. So you can change it. Then you have the sample type. So sample type can be of 3 different choices. The first one is sample. This means single stain control. Okay. The second one is negative control. And FCS Express automatically sets the unstained cells.fcs as a negative control. Why this? Because still, remember, FCS Express is looking for meaningful information into the file name. In this case, it did find the unstained words. So this is why it's giving this name as a label, and it's setting, these as a negative control. And then I have a last column, okay? The third type, just to anticipate, the third type will be the autofluorescence, okay? When you want to extract the autofluorescence, when you want to measure, that's the right word to use, not extract, measure the autofluorescence on your sample. The fourth column is which negative control you want to use for each single stain control. Okay, this is really important. Remember, we want to match, okay, because we need to subtract from the single staining control. We want to subtract the unstained profile, the unstained spectrum. So you need to match apple with apple. And in this case, we can use the negative control. Now, again, if you know that in your, for example, CD3 positive sample, you have a negative peak, in this case, I do actually, you can also set use self as negative, okay? Feel free to do that. Okay, step 1 is done. We review the label, the sample type, the negative control. In this case, FCS Express did a great job. Everything was already okay. Then select the select the scatter gate parameter. So automatically FCS Express grabs the for scatter say scatter. If you want to do something different, just open this drop-down menu and select whatever you want. Then step 3, select parameter to unmix. So you see here, you have the ability, specifically this file comes from an Aurora. In this case, Aurora save the single detector, and the single detector can be accessed either as single laser, like just the UV, violet, or blue, or the whole spectrum. I cannot see why you should use like a single laser unless you want to do something very very specific, like comparing different instruments. But otherwise, you will usually go with the full spectrum. Now, in version 7.8, which is the one that I'm using, which is the one that we released last week, we redraw the whole compensation and unmixing wizard in a way that as soon as you will select here, in this case, the spectrum, FCS Express will automatically create all the pages with all the histogram, all the spectrum plots, all the density plots automatically. So I'm going to click here, full laser, and FCS Express is starting working for me. And you will see now it's already there. You can see now that at the bottom we have a bunch of different pages. You see here. Okay, so we do no longer have the build histogram button. We still have step 4. Let me close 1, 2, and 3 to make a little bit of room. We still have step 4, which is just nowadays to report if there are any issue. Which issue you might see? Well, for example, if for any reason, okay, you label 2 parameters, 2 files with the same label, let's say CD3 FITC and CD3 FITC, well, that's not going to work. Okay, because you cannot have 2 parameters with exactly the same name. So here, in that case, you will see a message saying, looks, two parameters share the same name. This is not possible. Go back to step 1 and fix it. Okay, so step 4, it's to find issue like this. Let me close. Okay, let me close here for a while. Let's go back to our layout. Again, what you see here, it's what you were able to see in the past, also with compensation. So we have first page called scatter plot. In this page, you see one plots with one single thing control. In this case, the CD4BUV737, and one or multiple plots displaying the density plot with the scatter gate from the negative. So now we only have one negative control, the unstained cells FCS file. So we have one plots here below. If you have multiple negative control, you will have multiple plots here. Now, in this page, I will repeat this even later. In this page, just adjust the gate in a very general manner. Do not do anything specific, anything super detailed. Do not use data specific gate in this page. Okay, just have a look at the gate and do some general and macroscopic, let's say, adjustment. Why that? Because we will have time and option to change the gate properly in every other pages. So do not do it here. Now we can move to the first page, actually, the CD4BUV737. This is the first single thing control that we're going to review. Every page is made like this. You have a density plots with the scatter parameters at the top, and it's a good way to find out whether the scatter gate is okay. Then you have an histogram with a marker. In this case, you only have one marker, you see, because we are using an external negative, not self as negative. So the negative population will be defined in this page. If you do not select the universal negative, so the external negative, and you set the CD4 to use self as negative, then you will have two markers here, one for the negative, one for the positive. Now, this is the moment in which you define which population you want, which peak and which part of the peak. And what you see at the bottom, it's actually the spectrum of what you gated with the marker. You see the spectrum, it's live updating. It's really useful. It's really useful. Why? Because in this case, this sample is super clean. You see, we only see one single spectrum here, blah, 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 blah. If you start seeing something like, I don't know, here, and you have two lines, it means that you have a contamination. In that case, your sample, it's really bad. So this spectrum plot, it's really good to quality control your single stain sample. Then let me zoom out, and we are going to do this for every other page. So next page, CD8 BV650. The scatter gate, it's okay. I will resize this. It's clean. I move on. CD3, scatter gate, positive peak, plot. In this case, you might see here we have a little bit of contamination. This is probably like one dot, one event, okay? You might not be super afraid of this because anyway, we are measuring here the median or the average anyway, I mean, a central tendency. So one single events will not make much difference. I should check later on. It should be the median of every single detector. Okay, so CD56, let me clean a little bit my monitor. Scatter gate, my peak, okay, you see it's live updating. C19, unstained. In this case, you only have one peak, of course, because it's the unstained. So this is the negative. This spectrum, okay, is the one that will be subtracted from every other. You see? So this is the C19, okay, plus the autofluorescence. So we are removing this to actually have the right signature. Okay, you don't need to do anything else. So if you go back to compensation and unmixing, okay, what we have done was step 1, step 2, step 3, step 4 without error. You see step 6, okay, you do not need in 7.08, FCS Express 7.08, to click on calculate metrics, because now we are automatically recalculating the metrics. Okay, so if I go to the unmixing metrics page, now I can see my library. Every column, it's called nMember. It's the signature of a dye, okay? And it's the normalized signature. So you see that the highest point, the brightest channel for CD4 UV737, it's here, UV14 area, it's 1. You should look at these in a transposed way, okay? If you flip it, if you put it like this, okay, you have all the detector on the x-axis, and then you have the profile like this, blah, blah, blah. So those value are those value here, normalized to 1. And then you have the profile for CD8, BV650, BV711, and so on. So this is our unmixing matrix or library, call it as you want. So let me go back a little bit on my layout here, and let's have a look at any of my single standing controls. So why FCS Express, actually how FCS Express decided to display this UV14 for the BUV737, because UV14 is the brightest channel, as you can see here. This is UV14, okay, it's here. Now, if you want to, for some reason, if you want to change the choice that FCS Express did, and you want to use something different, for example, for some reason, you might say, okay, I want to use this one. It might be like R5, okay? You can go here, open step 5, and change the detector selected by FCS Express in this column. So we are dealing with CD4, which is this line. I can change this from UV14 to R5. And while I'm doing this, have a look at the histogram. I'm clicking on R5. Okay, if you look at the histogram now, it says UV violet, blue, yellow, green, red, UV14. As soon as I will click on R5 here, my histogram will change accordingly. Okay, now it says R5. You see here. So I usually, if you want to do this, I usually suggest to do it before reviewing all the pages, because when you do this, FCS Express recreate the histogram, at least in this version. So you might need to go back and readjust the other markers. So just do it at the beginning. But anyway, this is a way in which you can change the detector, the brightest channel that you want to use to define the positive population. There is also another way in which you can do this, but this depends on your user option. If you look at these, okay, you see I do not have any access to the single detector. Okay, the same if I open the parameter list from the density. I have no access to the single detector. This is why I cannot change the brightest channel here. I have to go to the step 5, which is easy to do. Okay, so it's fine, it's easy, it's super fast. But I want to mention also the other option. If your user preferences, and now I'm going to open, are different than mine, options, data loading, instrument specific setting, go on Cytec Spectral Flow, for example. This is a specific user option that we have if you're dealing with Cytec data. Okay, you have an option here that says delete fluorescence parameter after spectra merge. Okay, by default, this is checked. It means, as you see in my layout, that you do not see in the parameter list the single detector. But if you changed this in the past, so if you remove this checkbox, and it means that you are not deleting the single detector, you can access the single detector from the parameter list. So in that case, you can simply click on the axis and change and select the parameter from this parameter list. So in that case, you do not need to go to step 5. Okay, 2 ways to do the same stuff. What you see here So step 5, it's because not all instruments give access to the raw detector directly. Okay. Okay. Before closing these, let me go to the last 3 pages that we have here. FCS Express automatically create those 3 pages. One is called Visualized Metrics, Visualized Mixing Metrics. So this is a plot depicting the normalized spectra for every dye. It's basically graphing the column that you see here, the column of your unmixing metrics. And indeed, what FCS Express is doing, it's creating this page, creating a spreadsheet, reporting all the numbers here, and plotting those columns into a scatter plot. So what you see here are the spectra, the normalized spectra for those 5 dyes. The beauty of FCS Express is that now it's so fast with this implementation. Remember, I told you that every time you change something, FCS Express re-updates the unmixing metric. So if I, for example, if I show you 2 different pages, okay, I have the unmixing metrics on the left with my graph, and for example, I have the CD4, okay, here on the right. Now, if I move my marker here, you can see the CD4 column, okay, changing in real time, you see. And actually, if you look at the graph, you can see slightly differences in the black one, okay. If I do like this, you can see that my black line slightly adjusts. They are minor adjustment because they are minor change in the number, but everything updates live. It's really amazing. And then we have, let me also open here a second additional page, which is the spillover spreading metrics. And we also have the cross-staining index metrics. Okay, the cross-staining index metric is really of interest for people working with Cytec instrument, because it's the cross-staining index. It's one of the value that are usually displayed in SpectraFlow. Worth mentioning that you can go here, for example, and also apply conditional formatting if you want. Okay, we have many. You can do that. And again, those are all updating live. So for example, if I move this CD4, you can see that the metrics updates live. It's really, really, really fast. The same, it's true for the spillover spreading metrics that you can see here, moving and it's updating live. Okay, so let me close and let me move to the next example. We will be faster because we will not go through all the description of the wizard. We already know how to do that. So again, to summarize, in example 1, we had a common negative control because we are using the same media, same type of cells, same type of beads, whatever, for all the single stain control. Now, in example 2, we have an additional or a bunch of additional, here we go, a bunch of additional, sorry, let's move this a little bit down for the moment. Okay, a bunch of additional single stain control that are done with different media. So for example, this is, let's imagine this is the negative control of lymphocyte. This is the negative control, so the autofluorescence of lymphocyte. So for those two, I can use a negative control, a non-stain control with lymphocyte. But then I have this one, and this can be made with another cell type. I don't know, monocyte, neutrophils, a cell line, or maybe it's made with beads. Anyway, you have a different negative control, different autofluorescence. Okay, so you cannot use this one for this sample. You should use its own matching negative control if you want the pure yellow spectrum. Okay, so always compare apple with apple and peers with peers. So let me go back to my example. Okay. And in this case, we will load different single staining control. Okay. we have done this. Now we do this one. You see, I have still CD3, CD4, and CD8, and those are made with lymphocyte. But then I also have CD15, which stain neutrophils, and neutrophils are basically all positive for this marker, so you do not have a negative peak, so you need an external neutrophils negative. And then you have the CD14, which is basically similar because it stains monocyte. Monocytes are all positive, but there is no negative population for CD14 on monocyte, so you should use an external negative. And then we have Alexa Fluor 700 stained on a bead. In this case, I can tell you that there is a negative peak. So for this last control, I can set it to use self as negative. Okay. Now, I will go back to tools, compensation and unmixing, new unmixing, and I will start loading the data. Okay, the data are those one. So I will load here CD3, CD4, CD8 with my negative. Okay, this is fine. I can also load the 123. Let's just start with those one. So CD3, CD4, CD8 will be set to use the unstained. This is the unstained that we used before. The CD123, it's made with beads. You see, it's pretty smart, FCS Express. You see, here we say cells, 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 cells. Now we say beads. So it automatically set the negative to use self as negative because it doesn't find any negative control made with beads. Okay, so if you find a good way to label your control, you will save you will save time while setting step 1. Then I'm missing the CD14 and the CD15, okay, and their control. Now, what I can do, so the easiest way, which is what I'm suggesting, okay, it's, you see, in this unstained control, I know I actually have multiple population. This is like peripheral blood or PBNC or whatever. So if I want to use a different population from the same file, the easiest way is to simply create a copy so that you have different file name of the same file. So you see, I can create 3 copies. If you want to be fair, you can also say like mono, just to remember that this will be used for the mono, but otherwise it's just enough that they have different name, okay? Neutral or whatever. Now I will load these 2 and these 2 to my data list. So you know that the 3 unstained file are basically identical, right? We just change the name. So why this? Because now I can say, okay, for the CD14, I can select the unstained mono. And for the CD15, I can set the unstained neutral. Okay. And now we can move on and do the same we did before. So forward scatter, side scatter, which spectrum, the whole spectrum. And now FCS Express is creating all the pages. Let me dedicate a few minutes to this because now, remember, we have different media, so we will need different gates. So on page 1, now we have multiple plots at the bottom because we have 3 negative control, 1 for mono, 1 for neutral, 1 for lymphocyte. This is the original file. At the top, we still have a single stain control as an example. This is still CD4BUV737. Again, do not create any data specific gate yet because you will be able to do that later on. You see, we have 3 pages where we can set the data specific gate. So since most of our sample are made on lymphocyte, just set the gate on this page to be good for lymphocyte. Okay, so forget for the moment about this one and also for the monocyte. Okay, then CD4, let's briefly review these, like CD4, then CD8, okay, then CD3, CD14. Okay, this is the scatter gate. It's not okay. We want to create a data specific gate. So gating, data specific, and now we can move it specifically for these CD14 single stain control. You see, we have no negative. This is why you need an external monocyte negative control. Let's do the same for the CD15. Okay, click, make it data specific, move it up. We have a shortcut. Instead of clicking on data specific button, you can also press Shift on your keyboards, hold it, and then move the gate. Okay, we will do it later on. 123, this is bits. We set it to use self as negative. So let's do the shortcut. I'm pressing Shift till, and now I'm moving. I'm still pressing Shift. Now I'm releasing Shift, and that's it. And you see, we set it to use self as negative. So now we have two markers on the same histogram, and we have two spectrum plots to check the quality of our single stain control. We didn't finish. We have not finished yet. So this is the unstained for neutrophils. This is why I told you it's good to report the name, because it's easy then. And I will move this on neutrophils. So this will be the negative control used for neutrophils. This will be the negative control data specific gate for monocyte. Okay. And last but not least, the unstained control. This is for lymphocyte. You don't need to do anything else, right? So here is your visualized metrics. If you go to tools, compensation and mixing, you can have a look at the library, okay? And again, here we have the spillover spread metrics, we have the cross staining index metrics, and so on. So you see, my point is to show you that FCS Express is really flexible. You see here, we defined multiple negative for multiple single staining control in a very easy way. Last but not least, let me close. Now we are on this other sample, this other example, in which we do not only have, we're not only extracting pure signature from fluorochrome, from dyes. We want to also being able to measure the autofluorescence of one or multiple population. Okay, so the idea is that we are not using this in this column as a negative control. We are using this to the left. So this will be an additional dye, an additional fluorochrome. It's not actually a fluorochrome, it's just the autofluorescence profile of a cell type. So let me go back here. And here we go. So this is the last example, then we will play a little bit with the metrics. So you see, example 3, I will go straight. Compensation and unmixing, new unmixing, and let's say CD3, CD4, CD8, CD123, CD14, monocyte, unstained cells. This is what I need just for the positive and for the negative, right? So the 3, 4, and 8 will be set to use the lymphocyte as a negative control. Here we go. The CD14 will use the monocyte, okay? The 123 will use self as negative. Now I want to add the autofluorescence. It can be 1 or 2, it doesn't matter. If you just want to add 1, just select 1, for example, this one, okay? And set it to be an autofluorescence control. There is no need for the negative because you do not need to extract anything. That's already the pure spectrum of the autofluorescence. Okay, so if we go back here, you see in this case, here below, there is no negative because this is already the pure spectrum of the autofluorescence. Now you can add as many autofluorescence as you want. So select scatter, go here, select the whole spectrum. And now FCS Express will create all the pages, and we will have an additional page for the autofluorescence. Now, you might see, let's see here. Oh, yeah, this is a good example. You see, I have a warning, okay, in step 4, and this is because I have duplicated labels, okay? So let's review here. You see, I cannot call two things in the same way. These will be called, I don't know, AEF lymphs. Okay. Now it should be okay. What else? So I was saying, we have a new page now which is dedicated to the autofluorescence. Now, if you see something like this, do not go crazy. I mean, this is just telling you that multiple, okay, more than one control share the same brightest channel. It might happen. And in this case, it really makes sense, because you remember that the unstained cells are basically the same 5 duplicated. So they have basically the same spectrum, right? Okay, FCS Express, it's not really looking at, now it's not really, it doesn't really know that we want to move the gates on one sample. So overall, those two files are exactly the same. Okay, it might also happen with actual dyes. So if you have a dye with a spectrum like this, okay, and another dye with a spectrum like this, so they share the same brightest channel, but they are still different. So this is just a method that tells you that the brightest channel is in common. But if you know that those two dyes share the same brightest channel, but they are still different, that's fine. That's fine. Okay, so let's close this. Okay, I will change this to lymphocyte. And the first one, here is it. Okay, this is the page dedicated to autofluorescence. Nothing special, because it's just an additional end member, an additional dyes that you want to unmix. And then you have the CD4, you have the CD8, and blah, blah, blah. Of course, you will have, let's move to the CD14. We will move to the monocyte. We will have the beads. We will move it here. And then we will have the unstained for lymphocyte, the unstained for monocyte. Okay, and that's it. So now if I go back and I look at my unmixing matrix, you see that I do also have the autofluorescence. Autofluorescence is nothing magic. It's just an additional column here. It's an additional signature that you can unmix, that you can quantify. Okay, so sometimes I heard about I want to extract autofluorescence. You're not extracting, you're just measuring, okay, in the same exact way you're measuring BV711, Alexa Fluor 700, 710, and whatever. You're just measuring, okay? So now let me close this and let me open a layout in which I have created an unmixing matrix for all the sample, all the single stain control I have in this data set. So just to save a little bit of time, but now you know how to do that. So you add to step 1, you define which is the positive, which is the negative, whether you have multiple negative, whether you want multiple autofluorescence. In this case, since I was able to access the monocyte neutrophils and lymphocyte, I actually extracted 3 different autofluorescence. So this is my panel. You see I have a bunch of dyes here on lymphocyte, then I have 2 on beads, 1 on monocyte, 1 on neutrophils, and then I have 3 autofluorescence. You see here I have all the different pages, okay? It's exactly the same we saw before. Now my unmixing metric, it's much bigger, okay? You see here. Okay, you might have like 30 columns depending on what you want to do. Now, once you have this unmixing matrix, you can say, okay, now I want to see whether it's okay, whether my population are properly aligned. It's the time when you start using the matrix. So let me show you a few stuff. So if I open, this is just a new page into this same layout. Let's say that we want to quality control. Okay, I'm dragging and dropping, for example, the CD4 single staining control. And I will create very quickly a gate on lymphocyte. Okay, let's simply call it gate 1. Now, I didn't run the unmixing. I have my library, but I didn't use it yet. This is why if I go here, I cannot see any unmixed parameter. This is expected because I didn't run the unmixing yet. Now, how to do that? It's very easy. You have 2 options. You can drag and drop these unmixing metrics on top of the plot. And now you see this plot says unmixing transformed, and now I can access the unmixed parameter. Those are all the column in my unmixing matrix, all the dyes, all the autofluorescences, formally all the end members. So you see here, I can say this is CD4, so I will load the CD4 versus CD8. Okay. If you want to double check CD4 versus everything, you can very quickly go to multiplots, all by X in this case, because I want to keep the X-axis fixed. And then this is a new stuff in FCS Express 7.8. We have this filter box. So I can clear the selection and just say, for example, ordinary. This is the suffix, which is added to all. Select all. Maybe I don't need the autofluorescence, and click OK. Now I have, you see, CD4 on the X and everything else on the Y, if you want to see whether everything is aligned. Now remember, I mentioned about the options. So the unmix and transform is what you see at the top in the title. If you want to make it shorter, like unmixed, okay, now the title just say unmixed. And if you find this ordinary square too long, you can make it shorter. Sometimes I used to do like OLS. Now it's shorter. Yeah, you can do that. You can also change the actual name of the parameter. For example, let's say that this CD14 per CP monocyte, it's too long, and you just want to get rid of the monocyte tag. You can go here, right-click, rename, and remove this. Click OK. And now that end member will be called differently. So now you see it just CD14 per CP fluor. You remove the monocyte. So it's pretty flexible. Then I showed you the drag and drop. Okay, we also have these this option here. You see, apply to all plots. Well, I would suggest to not do that if you're working in a layout, in the same layout in which you calculate the unmixing, because clicking on apply to all plot means also apply the unmixing on this plot. You don't want this, right? So this should be the raw data. So if you're working into the same layout, either use drag and drop, or maybe you can use the other button. So the other button there, let me highlight it. Now it's not available. The other button says apply to selected. So if you select a bunch of plots, then you can apply. Now you see that also the plots at the left, it says unmixed. Other thing, if you want to automatically apply this unmixing, when you will load the next data file, just right click and click on set as default. Okay, so FCS Express will load this unmixing. So we'll apply the unmixing, we'll run the unmixing automatically. So now if I move to CD8, okay, you see it's automatically unmixed. If you do not do right click set as default, the unmixing will be lost. I mean, you're not going to lose the library. It's just that the plots will not be unmixed as soon as you will load the new file. Now, let me also show you, which is pretty cool. Since this layout might be quite big, right? So with like 63 detector, you might have like 30, 40 different dyes, 40 pages, autofluorescence. You might not really want to work into this same detector. So what you can do is to simply go here, okay, and save this. I will save it, for example, in my folder, okay, unmixing webinar. Now I can open a new layout. Sorry, file new. Okay, I can go to tools, compensation and mixing, and I can open the unmixing that I have created before. I can load it here. So I will have a blank layout with no pages, no plots, whatever, but with the unmixing. So now I can load my data. Okay, I can load all of them. You don't need to load this. Okay, you can select all and unselect that one. You don't need to select it. It's not an FCS file. Then again, if I drag and drop, remember you will have to, let's do it, drag and drop to open a plot. It will not be unmixed because we didn't right click set as default. So if you do this, remember to either drag and drop or to apply to selected, or to apply to all. Alternatively, okay, if you right click set as default, then as soon as you will load the file here, it will be unmixed. Okay, so you see we are retaining this and this label. Now, two things that are really cool. Let me, for example, just display for a scatter, side scatter, small gate here, and I want to open a plot. Let's do something very simple, like CD4 versus CD8. And I'm going to load, for example, the fully stained. It's this one. Okay, this is the fully stained sample. So what I'm looking at, it's at my sample, my raw data, unmixed with the whole library. Okay, so FCS Express, it's trying to measure, okay, the abundance of every single column, of every single die, every single end member in this library. Okay, but you might ask yourself, well, especially if you are measuring multiple autofluorescences, this is a good example. You might ask yourself, shall I really measure multiple autofluorescences? Because, you know, if two autofluorescences are really similar, okay, if they are not enough different, okay, measuring all of them might be detrimental for the unmixing. Okay, ideally it's the same thing as trying to unmix two very similar dyes. Okay, in that case you might see issue. So what you can do in FCS Express is to compare, okay, different library. So let's call these unmixing, mixing with 3AF. Now I can create a copy. This is a copy of my library. Okay, I can copy and paste. And I can call these, for example, with 1AF. And I want to see the difference. Okay, maybe I can also create another copy and call this without, no AF. Now, if I go here, I can simply uncheck. You see the column, and maybe just keep this one, or maybe just keep this one as you want. This is good to switch off and on multiple or even a single end member. And here I should do uncheck, uncheck, uncheck. Now I can simply create like 3 copies of this plot, like Control D, if I want to compare. Okay, and then I can drag and drop. So, well, I will drag and drop this one here, 1IF here, and here. And I want to compare the same, right? So this is CD4, CD8. This is CD4 and CD8. Okay, so it's just an exercise, just for you to show you, for me to show you that you can. This is library 1, this is library 2, this is library 3. Okay, and you might find out differences. So for example, you see that this negative, it's much different than this one and this one on the y-axis on the CD8. Okay, so also here you see it's much different. So this is a way in which you can compare and let's say evaluate the effect of including or not, measuring or not an autofluorescence, or technically speaking, of any dye in FCS Express of your library. Does it make sense? Is there any question? Any doubt, anything you want to ask? Okay. So just to summarize a little bit, with FCS Express, you can run the unmixing, and we try to provide you with a user-friendly interface as usual. So this is why we really mimic the compensation wizard. Now, you can, I don't like this one, can be measured. Okay, autofluorescence can be measured as any other dye. Okay, you can also measure multiple autofluorescences. It's also good that you can define a lot of different negatives if you're using mixed media. So this gives you really a lot of flexibility. You can activate and deactivate, as we saw in the last example, different column, so to switch on and off a dye or an autofluorescence. And as you might have noticed, the unmixing, it's really fast. Like you drag and drop and it's immediate. Like, so that was not a super huge file, like 50,000 events, but I mean, in that case, it's like a fraction of a second. And if it's like 1 million, it will probably take half a second, but it's still very fast. And then remember, you have the ability to plot the unmixing metrics. Okay, so you can do that actually if you have, like in this case. No, this is the case in which the built-in metrics visualizer has been automatically created by FCS Express at the end. Okay, this one. But even if you are in the other scenarios in which you only have, you didn't calculate the library here, you just have the library because you imported, you can simply right click and click on build metrics visualizer. Okay, FCS Express will create a new page. It's super fast, and you see here. You can also, this is good, you can also go here, overlay, and say, okay, just want to view the first three, okay, the autofluorescence, and I can hide the remaining. So I can click on make them invisible. And then you see I can only focus on the three that I want, basically column C, D, and E. So this is also worth mentioning. And yeah, so thanks for your attention. I will stay here for a few more minutes. So if you have any question, feel free to type in the chat. So I see a question about data from Aurora. So if you load unmixed sample from the Cytec Aurora, can you modify them here? You can apply a compensation on top of that. So basically, those data are, so the unmixing has been performed before the acquisition. It's not like with the compensation, in which the FCS standard format save the raw data and the compensation metrics. In that case, SpectraFlow saved the data already unmixed. Okay, so the only thing you can do is to apply a compensation on top of that. Then, can you modify the unmixing metrics created in SpectraFlow? Well, so far, SpectraFlow doesn't give access to the unmixing metrics, so there is no way to do that. What I would suggest is just load the single staining control and run the unmixing in FCS Express, because in that case you also have the live update. Okay. So let me see. I see other question here. So yeah, I see another question about re-unmixing. So usually you start with the raw data, right? But if you have exported from SpectraFlow both unmixed and raw data, you can also end up with two different unmixing. Okay, the original one from SpectraFlow and the new one from FCS Express, and then also compare. So that's also possible. So there is a question: if my single staining control are with beads, how can I unmix autofluorescence? Well, you need to add a control, and that control should be made with the cell type that you want to measure the autofluorescence of. So like in my case, I added like 3 control, monocyte, lymphocyte, and neutrophils, and I set them to be autofluorescence control. Then all the other one can be whatever you want, but for the autofluorescence, you need to use the sample that you want to use to measure the pure spectra. Okay. Yeah, so we are going, this has been recorded, so we will upload on our website and on YouTube in a couple of days. So you will receive actually an email when the recording will be available. Another question. So the single stain control should be beads or cells? This is actually a very, very good question. So I think the answer to this question, it's not really universal, because I see people saying that there might be some difference, okay, and other people saying that might not be some difference. So technically speaking, mathematically speaking, since you are subtracting the negative, if your single stain control you made with beads plus FITC, and then you subtract the beads itself, you should end up with the pure spectra of a pure spectrum signature of the FITC. If you do that with cells, you should end up with the pure spectrum of the FITC again. But I know there are people that saying that maybe the binding it's different, okay, from the antibody with the beads, the antibody with the cells. Maybe there are some interactions. So I think this is a very, very good question, but since really I cannot really tell you whether one is better than the other. Okay. Yeah, you should be able to mix also with single stain control from Sony. Yeah, feel free to give it a try and let us know. Okay, I think there are no more questions. So I was really glad to have all those questions, and thanks for your patience, for your time today. Feel free to play with FCS Express, try to unmix, try to analyze your data, and if you have any question, feel free to reach us at support@denovosoftware.com. Many, many thanks, and have a great day.